Thank you, Nathan. Welcome, everyone. My name is Daniel Moyer, Sales Support Trainer here at SimpliPhi Power, Briggs & Power. I also have Nathan Heston on the line with us this morning. Hi, Nathan.
Good morning, everybody. Welcome.
So we're going to get started here in just 1 second. A few housekeeping items before we get started is this is a NABCEB accredited course. It's good for 1 hour of continuing education credit. At the end of this presentation, I'm going to go ahead and show my email. Go ahead and pop an email over to me. Be sure you include your full first and last name. Spell it out for me, because if I don't get the name right, sometimes they don't like to accept credit certificates that I'm going to issue you without your full name. Another item is, if you have any questions during the presentation, go ahead and put them into the Q&A chat feature. That's a little button either at the top of your bottom of your screen. It says Q&A. Don't raise your hand, because I can't really act on that. We'll just go ahead and pop the questions in there. We'll try and answer some of the questions during the presentation. And if we don't get to them during the presentation, we'll be sure to carve out some time at the end. So again, welcome everyone. My name is Daniel Moyer, and let's go ahead and get started. A couple of quick things. So the title of today's presentation is Environmental Considerations. We also call operating in extreme environments. A few items really quickly on the top of my head going into this meeting this morning is, as we grow with energy storage installations across the country, a lot of jurisdictions, a lot of AHJs are not wanting to see these batteries put into garages or inside. What that means is that we're now being forced to put these battery systems outside in more of the elements. So as these jurisdictions become more rigorous with putting things in garages, and maybe they still let you put them in garages, but now you have to put in a parking bollard. Maybe they'll let you put it in the garage, but now you have to put in extra drywall or X-Rock or fire-rated drywall in some of the walls. Maybe they'll let you put it in garages, but now you have to do sprinklers or heat detectors, or not smoke detectors, heat detectors. So the opportunities to go outside are more going to become more, I think, attractive and more popular as we kind of grow this industry, which means that temperature considerations are going to become more important. Another thing that kind of brought to my attention this week was in Florida with this most recent hurricane. There was making the news of some of these EV cars catching fire due to salt spray. And we're going to talk a little bit about salt spray today, and that's one of the environmental considerations. So, and some of these cars, take 5-6 hours to burn out. So look it up if you're wanting to know a little bit more about that. Environmental salt spray is also going to be discussed today, not just temperatures. It's important to understand that there's an operating temperature, which is idle, or when we're discharging the battery. And that temperature window is a little bit larger than the charging temperature window. Now, the windows you see here aren't necessarily specific to just our SimpliPhi batteries. These can hold true for many other lithium-ion battery-based chemistries. So really, you cannot charge a lithium-ion battery below freezing, or you could damage it. And so we'll talk a little bit about what that actually means and open that up. So again, operating temperature, which is discharging or idle, is -4 to 140 degrees Fahrenheit. Charging, 32 degrees Fahrenheit up to 120 degrees Fahrenheit. So when we're talking about them sitting idle, right? They can be sitting idle in maybe a cabin that's off grid, that's only being used part of the year during the summertime. These batteries can sit there for an extended amount of time without losing their charge, right? We have a very slow self-discharge rate, about 1% per month. And it can do this in pretty low temperatures. So that can be a big benefit, a big, nice plus to using our batteries when you have a site that's only in a part-time cabin. For 6 months, we can have them down to 14 degrees Fahrenheit, which is well below freezing, up to 77 degrees Fahrenheit. 3 months, it's a little bit larger of a temperature range, down to -4 degrees Fahrenheit, up to 113 degrees Fahrenheit. There's two main types of product line that we offer here at SimpliPhi Power. There's the Phi battery, which is the 3.8 Phi battery you see here. We also have an amplified battery, which is exactly like the 3.8 Phi battery you see here, but the amplified battery has a more advanced battery management system that's capable of communicating to pieces of equipment. We actually do have a third battery that we just released, our SimpliPhi battery, which is the 4.98 kilowatt hour battery that we recently released in partnership with Briggs & Stratton. And I should say also that we do have smaller 12 volt and 24 volt battery lines. But for the sake of this presentation, we're going to focus on the Phi and Amplify. The Phi, the more of the simple internal only battery management system, does not have an internal temperature control system, right? It doesn't have a built-in thermistor. So it's really important that we program pieces of equipment so that we're not charging the battery below freezing. So it's important to understand that it's up to the customer and the installer to make sure that we've set those parameters in the pieces of equipment so that we're not going to damage that battery, whether we go too cold or too warm on a charging cycle. With the amplified battery, like I mentioned, has a more advanced communication system, and it actually has a built-in 10K thermistor that's constantly monitoring temperature, internal temperature. And we're going to talk about this here in a second, that there is heat generated in these batteries. There's heat generated in some of these battery cabinets that can make the internal temperature of these batteries be, I would say, significantly or quite a bit warmer than what an ambient temperature is. So by having this amplified battery, having its thermistor built in, measuring cell temperature, it can then transmit that temperature up to a piece of equipment, or more precisely, it could transmit that temperature to the internal battery management system, which then recognizes what the temperature of the cells are, and then can communicate up to your charge controller, up to your inverter charger, that it's starting to get cold. I need to reduce my charge rate, or at some point it's too cold and I can go ahead and stop charging me. So there's two layers. One, the battery management system will communicate this to the piece of equipment. And if the piece of equipment isn't listening and it continues to charge below a certain point, the battery management system will actually just open circuit and prevent that charge rate. Talked about this just in the previous slide briefly. There's ambient temperature. You can see here this picture on the right. That's a beautiful ground mount array, pole mount there. And you can see those panels are tilted pretty steep, right? Because it's winter and we're trying to catch that sun in the winter, which is pretty low in the horizon. And you see that shed in the background there. That's the power shack, right? So that ambient temperature in that field there is going to be a lot colder than what I expect to see in that shack, than what I expect to see in a battery case itself. So when we're charging, before it gets too cold, again, the point is that we need to make sure that the battery isn't charged. What can happen if you start to charge below freezing? Well, you can get a loss of capacity, potentially a reduction in your cycle life if you're really hammering on the battery at a C/2 rate. So by reducing the charge rate, we can prolong the battery life when we do charge in low temperatures. It's important to understand the Phi battery, which is the standard Phi battery, does not automatically reduce the charge rate based on temperature. It's up to you, the installer, the homeowner, to program those pieces of equipment to not charge below freezing. You're going to cause out of warranty damage to the battery. With the amplified battery, with that battery management system, it doesn't automatically regulate the power coming into the battery, but what it can do is communicate with a compatible inverter what the charge rate should be. Right now, we have communications compatibility with Solarc SMA Sunny Island, and our new inverter. So this is going to allow you to maintain that warranty. And you can see on the right there, even below freezing, we're still allowing a slight charge rate, almost a trickle rate, right? C over 20 at this point. A normal charge or discharge rate of our battery is C over 2, which is great because it allows you to have a relatively small battery bank size to provide a lot of power output. But when we get down to a cold temperatures, we want to curtail the charge rate to be pretty small, almost a trickle charge, a C over 20 rate. And Nathan, if you don't mind, actually, why don't you go ahead and chime in maybe and explain to us a little bit more in depth about what happens to a lithium ion battery when it does get too freezing?
Sure, Daniel, and thank you. So what's happening inside a battery as you're charging it? Daniel mentioned at the beginning of this talk, right, that the discharge rate is higher than the charge rate, or the discharge rate at extreme temperatures. You have a broader temperature range you can discharge at, and you can discharge faster at those temperatures. So the limiting process in this cycle, in the charging cycle, is getting the lithium into the negative side of the battery, which is known as the anode. And what's happening is a process called intercalation, and the anode is made up of graphite sheets. So you can imagine layers of hexagons, almost like what you see inside a honeybee nest, right? And the lithium is sitting inside the centers of those hexagons. And so to charge it up, we want to get the lithium in there, but at low temperatures, the rate at which the lithium can migrate into that graphite structure is significantly reduced. And if we try to charge rapidly at low temperatures, the lithium ends up building up outside of those layers, and it can lead to what is called dendrite formation or lithium plating. And what dendrite formation is, you can think of it almost as the growth of icicles of lithium, right? And that would be starting on the anode side. And if those solid dendrites, if those chunks of lithium build up large enough, they can actually puncture through the separator layer and short circuit the cell. So in an extreme situation where you're charging very rapidly, as you're trying to push the lithium into the anode, the graphite, it can build up these dendrites of lithium, which are, growth, which is what I was describing as something like lithium icicles, right? They can actually short circuit the cell if it punctures through the separator layer and reaches the positive cathode side. That's why you have to be very careful when you're charging batteries at low temperature. Additionally, this is not true just for our battery. This is true for any lithium battery that has graphite as the anode, which almost all batteries do. So it might be more depth than you wanted, Daniel, but that's kind of what happens to a battery. That's the physical mechanism through which damage can occur. So it's not that we can't charge below zero. It's just that we have to charge very slowly. And so the reduced charge rate is shown on the right side of that screen. So we can charge, down to negative 20 Celsius, which is significantly below zero. We just have to do it very slowly.
Yeah, Nathan, that's great. Thank you. I actually do love hearing more of the science behind it. I see one question, Nathan, in the chat. Somebody's asked, Glenn Brooks is asking, do we have a cabinet warming system to enable charging in too cold climates? We do, and we're about to talk about it here in just one or two slides. So insulation can be a tool to help mitigate the effects of cold weather. We do sell our Boss cabinets. If you're not familiar with them, we have a Boss 12 cabinet and a Boss 6 cabinet. It either holds 12 or 6 of our 3.8 batteries. It comes uninsulated from the factory. However, you can install insulation to help contain some of that heat inside the battery cabinet that's being generated from the batteries itself. Or perhaps there's other pieces of equipment inside that battery cabinet that are creating heat, like an inverter or a charge controller. That's going to be trapped and help maintain that heat inside. So insulation, I've heard of insulation being put on the outside of the cabinets. I've heard of insulation being put on the inside. A 1-inch thick foam insulation really fits nicely into the walls of these battery cabinets. And you can also put insulation under the batteries so that you're not getting a heat sink, right? You're not losing heat through that conductive metal to the outside. Make sure that the insulation that you're putting the batteries on top of is rigid and strong enough to handle the weight of those batteries.
So Daniel, those were all very, very important ideas, right? And one of the things I want to point out here from a science standpoint is the reflective layer on that insulating foam there. There are different types of foam that you can buy. The foam that's shown in that picture on the bottom has a reflective aluminum surface to it. And remember, as Daniel was indicating earlier, right, when a battery charges or discharges, it actually produces some heat. And so the batteries can help warm themselves, right, by going through a discharge cycle or going through a charging cycle. And if we're in an extreme low temperature environment, we want to maintain that heat that the battery is producing. If we could just do that, right, then the battery system wouldn't get too cold. So the reflective layer there will keep in some of that heat that the batteries are producing. And really at low temperatures, these warm batteries can give off a significant amount of heat just through radiation. And that aluminum there keeps that radiation from being absorbed by the walls of the cabinet and moving out. So when you do buy that foam insulation, it's important if you're going to line the walls to get foam insulation with that Reflectix covering. I think Reflectix is the brand name there.
Yeah, and that's a great point, right? So there's 3 ways of heat transfer, right? Conductive, convection, and radiant, right? So that radiant is the foam there. Apparently, also temporary insulation can be employed when it drops down. I haven't seen it, used temporarily as much. Usually, if you're going to go to the hassle of doing it, you just put it on and leave it. So back to Glenn's question, we do provide options in which you can add these heating pads underneath the batteries. Right, this is going to be in applications where you're really getting below freezing on a regular basis. If you have not a regular basis, it may be possible to rely on just the heat generated by the batteries themselves and not need some other active heating system. So in these applications, what we do is we actually do come and add a temperature sensor inside of the battery case. So you do have to custom order these to make sure that we're including this in the battery, right? We want to do this in the factory. And by doing this in the factory, we're getting a temperature of the cell temperature, not of the battery temperature or the battery case temperature. That allows us to only turn the heaters on when we really absolutely need to use them. The battery warming pads, of course, do consume. There are a load. So when we're going to size the system, we need to make sure that we're taking into account those consumption requirements of those heating pads. They are on a thermostat, so they will cycle on and off.
That's a great point, Daniel. I do want to go back and hit the very easiest thing that you can do for yourself. If you go one slide further, when we were talking about this foam, one of the easiest things, and Daniel did mention this, I just want to highlight it. Conduction is the main mechanism by which these metal cased batteries will be cooling, right? That those shelves get cold, the housing gets cold if these are in a cabinet, right? And by just putting a simple layer of foam under your batteries, it helps to isolate the batteries thermally from the environment. And as Daniel mentioned, the battery's internal temperature can be significantly different from the ambient temperature. So if you prevent the mechanism by which the heat will get out of the battery, right, conduction to metal shelves, etc., then you might not need more sophisticated methods. And of course, we have this heating pad option that's available to you too. So if you're installing in a really low temperature environment, ask us about it and we'll help set you up.
Yeah, thank you. Thanks, Nathan. That's a great point. You got to think about all the different ways that you can lose heat. There is third-party devices that can help control. A lot of charge controllers do have built-in temperature sensors that can then help regulate the charge rate to a battery. Ramp down or ramp up the charge rate. It's important to understand that these devices only consider ambient temperature and don't have that temperature sensor, which is built into the battery, which is the internal battery of the cell temperature. So in this case, the charge controller may curtail charging sooner or before the cells actually reach that low temperature, because it's measuring ambient, not the internal temperature. But it's still an appropriate method of curtailing charge at low temperature rates. This Victron BMV 712 is another great product. We don't necessarily endorse Victron. It's just something that we've seen that works really great. Hot temperatures are also a design consideration. You can charge these batteries up to 120 degrees Fahrenheit. When you're in an airtight location or a desert location, you can really get some high temperatures. So similar to cold weather, we can use a insulation to help mitigate temperature. And also it's important, again, to understand that concept that internal temperature may not be the same as ambient. Nathan, do you want to take a stab at what happens if you charge the battery when it's too hot?
Yeah, I'd be happy to talk with you, with everyone here about what happens at higher temperatures, right? So if we get too high of a temperature inside a battery cell as it's charging, what can end up happening, so inside that cell, the lithium ions are mobile by being based inside of an organic electrolyte. So we basically have a solution of lithium ions which move between the positive terminal of the battery and the negative terminal. And this is in all of the cells, whether they're pouch cells or in our case cylindrical cells. There are layers, right? There are layers of cathode and anode separated by this organic electrolyte. If you get too hot, the organic electrolyte can get local locations where it actually can vaporize, right? And if you get little pockets of vapor, those pockets can separate the cathode and anode layers. You can imagine it's just like bubble formation when you're boiling water, right? And so at really high temperatures, as we're charging, we can damage the cells from that type of a mechanism. Again, the rate limiting process is normally more in the charging cycle than in the discharging cycle, because it's migration of the lithium into the graphite, the anode, the negative side of the battery, is a slower process than out of it, right? It's easier to get the lithium out of the graphite and into the cathode side, which in our case is lithium iron phosphate, than vice versa. So there are several mechanisms which damage can occur, but it's basically too much localized heating inside the cells.
Great.
So again, we can discharge at higher temperatures. I think we go up to 140 degrees where we can be discharging. But on the charging cycle, we really don't want to be charging, especially rapidly, at any temperature above 120 Fahrenheit. Everything has to slow down as we get to high temperatures and low temperatures. Our
Great.
SimpliPhi battery can communicate that information to the inverter.
Great, Nathan. Yeah, the way you describe it is so I can visually see it in my head. Thank you for addressing that. Humidity. I live up here in Arcata, California, up on the Northern California Lost Coast, and we do have a lot of right on the ocean systems. They're on a cliff that's about to fall into the ocean. So we do talk a little bit about humidity and salt spray as well. What it is there's the condensation in the salt spray. That's what's really this liquid water with that salt is going to promote that corrosion. So really what we should do is we should keep in situations where we are that close to the ocean to salt spray. Let's think about using indoor installations or a battery cabinet that's going to keep that battery out of a condensing atmosphere. I will ask maybe Nathan here to chime in a little bit about this, especially when, from what I understand, how low pressure poses a direct risk to pouch cells, as pouch cells don't have a rigid housing. I'll finish this, maybe this slide here, Nathan, and let you chime in on that. But as you know, as you go up in elevation, air pressure is less. And I also understand that this has also a little bit to do, and we're going to talk about this a little bit later, is how we're able to airship our batteries. And if you think about going in an airplane, you think about the pressure rapidly reducing and increasing. So by having our cylindrical cells with that metal casing, the round circle, we're able to, it has to be a higher pressure point is actually going to cause something to collapse or not to function properly. Whereas a pouch cell, that pressure may be a little bit the smaller window. So to understand really is altitude provides no direct operational limit for our batteries. But keep that in mind that the inverter or other pieces of equipment may have an altitude limitation. Nathan, did you want to chime in on any of that?
Yeah, I'll chime in on both. So Daniel, I actually live about 2 miles from the coast, and salt spray is a significant issue for those of us that live, even a few miles from the ocean. And so what ends up happening is at nighttime, when surfaces get cold through actually radiant cooling, right, when they're exposed to the upper atmosphere. So any surfaces that's kind of pointing directly away from the Earth is not getting that warmth, that infrared radiation that's kind of hitting the sides of buildings. So we call that blue sky cooling. So at nighttime, surfaces which are facing the sky collect a lot of condensation, right? They get cold and then water condenses out of the atmosphere. And because we're near the ocean, we get this salt condensation on our roof. So it's pretty bad for our cars. But in addition, it can be bad for any metallic surface that's directly exposed. So like Daniel said, if you just put your batteries inside a cabinet, they will not get that condensation on them because they're protected from that blue sky cooling. So you don't get as much condensation. So that's a great point. On to altitude and its effect on battery cells, I can proudly say that our batteries are very resistant to altitude problems. So we can airship our batteries, unlike companies that use prismatic and pouch cells. So our cells are cylindrical cells. The cylindrical form factor has a steel case which encloses the battery cell. And that steel case, just because of its structural nature of a cylinder, is really resistant to expansion and contraction. So we don't really have any types of problems. We can have high elevation installs. We can even have our cells transported on airlines, which are going up to 25,000, 40,000 feet at times. We don't have these issues that companies that sell pouch cells and prismatic cells do. So that's a nice advantage. Of course, if you're going to very high elevation, you want to think about what Daniel's been telling you about low temperature, because normally with high elevation, the low pressure is not a problem for us, but you have to pay attention to temperature regulation. So good points, Daniel.
Thank you, Nathan. I've just been blown away by the number of not RVs that I see here on the North Coast, is the number of these van conversions, these Sprinter vans, these Ford Transit vans, and it's been really popular for a lot of these vans to kind of be off-grid systems. A lot of them have their own built-in Victron systems, and I believe, Nathan, I'm going to call you out. I believe you do have a van as well, and so what you're seeing is a lot of people putting solar and lithium ion battery storage in their vehicles. And as kind of a history of SimpliPhi Power, we were originally founded as OES Energy in the film and broadcast industry. So we've always been making these LFP cylindrical form factor batteries our entire history, since over 12 years ago. And part of the beginning of the end of our company is that we went to the military and had worked with the military at some of their forward operating bases. At the time, they were using lead acid batteries or generators, and they just weren't getting the performance they needed out of it. So at first, the military didn't want to use lithium ion battery technology because of the risk of cobalt-based chemistries catching fire at the time, we said, look, we have a safer LFP chemistry. So they took some of our batteries to the Aberdeen Proving Grounds, which is out on the East Coast in Maryland, I believe, and put the batteries through some very rigorous vibration, shock, and temperature tests. And it was shown that our batteries were tolerant of that vibration. You know, it's definitely nice to have something safe with a safer chemistry too, if you're going to be in something mobile where you're living, you know, perhaps the batteries are right below your bed in your camper van, for example.
I think that's an excellent point, Daniel. Both myself and Matt Walker, who's been a trainer here with SimpliPhi Power, have these vans, and I would encourage you as installers and battery experts who are selling these products to tell customers, you know, to really avoid the low-cost batteries when they're using it in a mobile application, especially a mobile home, because those vibrations can end up resulting in significant challenges for the battery structure, just in terms of electrical connections. And if you end up using a cheap battery, you might not have as good of a result. And the other point to make here is that we use what we feel is the superior battery chemistry, lithium iron phosphate, which does not pose the kind of fire risks that you can see with other batteries. I mean, Daniel was mentioning that, you know, some of the batteries that have caught on fire in Teslas that were, you know, in the salt spray on the East Coast. But battery fires are a consideration that definitely should be taken seriously. And so I would also encourage people never to use a chemistry other than lithium iron phosphate, you know, for this kind of mobile application. Just it's too dangerous, you know, and those vibrations can be a significant challenge.
Thank you, Nathan. We have gone through a number of testing, and we're going to talk a little bit about the UL 9540A testing here. So this is a picture here on the left of actually our R&D lab. It's down in Oxnard, California. So we're putting these into a lot of, you know, real world applications. I would say we're one of the most lab tested, field tested battery products out on the market to this day. Like I said, we've been around for over 12 years, and we've had these batteries in a lot of different applications. We've tested them not only internally, but also by third-party testing like UL and Intertech. So 9540 is a system level certification where you have a compatible battery and a compatible inverter that have been vetted to design to work together. 1973 is the battery module level UL listing. And then UL 1642 is the cell internally in the battery module UL listing. 9540A is a test protocol, and I'm going to talk about that here in a second. UN 38.3, this is what allows us to airship our batteries locally, like Nathan had mentioned. So they put the batteries through some safety tests, and if the battery doesn't leak, vent, or rupture or catch fire, then we pass the test. So they run it through some altitude tests, right? We're going to keep it at very low pressure to simulate what it would be like in a cargo hold of a battery, or maybe at the top of a mountain. They're going to rapidly cycle between high and low temperatures to test that thermal stability of the battery. Again, something you might experience in a cargo hold of an aircraft as it's going up to cruising altitude and then coming down. Vibration and even shock testing. Further, we're going to short the battery out and see if it exceeds a certain temperature threshold before it starts to cool down. Ours didn't. It didn't exceed 170 degrees centigrade, and it didn't catch fire. We also going to hammer on the battery. We're going to try and charge that battery much faster than it would ever see in a real life application, and make sure that it's not going to catch fire. Again, back to the UL 1642, that's on the cell level. So they put the cells themselves through some testing regiment, shock, vibration, drop, heating, short circuit it. If it passes, great, we can go ahead and incorporate it into a UL 1973 listed battery, where the battery itself is being tested to make sure that it's not going to experience a fire or an self-ignition or a self-propagation. And then 9540A simply verifies that components, the 1973 listing on the battery, and an inverter, which is 1741, can work together and make sure that there's no additional testing required to make sure that those two pieces of equipment are compatible. We do have the UL 9540A test as well. Now, those previous ones that are mentioned were essentially UL listings to make sure we put the batteries themselves, the battery cells, the battery system through some testing to make sure it didn't catch fire or didn't go into a thermal runaway. The 9540A test essentially is not a certification, but it is a test. What we do is we take one of our cells inside the battery and we wrap it with a thermal wrap, and we put a lot of extreme high heat into one of the cells. And in order to pass the 9540A test, you almost have to have a thermal event. And it wouldn't be appropriate to say that our batteries can never have a thermal event, but it would be appropriate to say that when our battery cells do have a thermal event, they off-gas, but the off-gassing isn't a flammable gas. And if it does off-gas and cause adjacent cells to catch, to go into a thermal runaway or to go into a thermal event, that it doesn't self-propagate. So a thermal runaway can absolutely happen in a cell, but whether it's self-propagating or unmitigated runaway is what we're looking for, right? So it's okay if a cell outgasses and expands a little to adjacent cells, but that it doesn't self-propagate to further cells. So I'm not going to go through the whole thing on the right here, but essentially what we do is we have to force it into a thermal runaway, and then we watch what happens. Does it spread to a couple adjacent cells? Sure. Does it spread to cells adjacent to those cells? No. Does it spread throughout the entire unit? No. Does it spread beyond the unit battery cabinet into your garage or to your house? No. So it was a really big win for us to demonstrate this safety testing. And we're one of the few companies that actually publishes this result on our website. So you can go to our website right now and download this big long PDF that documents all of these test results.
Daniel, those are some great points that you made there. I just want to point out, right? This is a testing process, right? And the UL, what they do is they heat up an individual cell to get it to the point where it gets hot enough that it could go through a thermal runaway. And the idea here is that, let's suppose that you have some event that happens. Maybe you've got a contractor who stupidly shoots a nail through a wall, and it actually penetrates a battery that's nearby. Or somebody drives into the garage and instead of hitting the brake, they hit the gas and crash into a battery bank, right? The question is, how's that battery going to respond? And so what UL tries to do is to verify the safety level of the battery. And so if you do somehow get one of our cells into a situation where it's shorted and gets really hot, what Daniel's pointing out is it does not transmit from cell to cell to cell, which is what would, result in a kind of catastrophic chain reaction burn down of a battery. Want to see some of these things happening? Go on YouTube and Google, right, thermal runaway of a battery. Our chemistry doesn't do this, but certainly there are competitors where you can see fires. And the last thing we want to have is for somebody's battery backup system for their home to catch on fire and go into a uncontainable thermal runaway. So this test that we've done really shows how safe our batteries are. And to prove that, we published the results. We published that video. We're one of the few companies that does publish our safety record because we're proud of it.
Yep. And some of those other companies, when they have performed this test, they realize that, and they're required to now implement various safety mitigation strategies because of what happens. So they means they have to have built-in fire extinguishers, metal cabinets to prevent flying debris, different safety features that are other modes of failure and make the battery more expensive. And we don't need those simply because we're not experiencing that inherently in the cell design. Lastly, I wanted to plug a couple of our training programs. With our partnership with Briggs & Stratton, we've now had a lot of our content on the Power Academy. There were several ways to access the site. I'm sorry, the font here didn't pull up. Nathan, if you want to maybe pull that up for me. There's a couple ways to do it. You can go to bluevolt.com. On bluevolt.com, you can access the Power Academy, or simply Google Briggs & Stratton Power Academy. You can set up a training portal, an account in this training portal. You don't have to be a dealer. You could even be a homeowner. You can do in-person training like we're doing here, or you can do in person where you can fly out to one of these locations where we're doing in person. We can do the live virtual like we're doing now. And there's even self-paced recordings online where they break it down into little sections, and you could do it self-paced. This is just showing you how you sign up for it. It's pretty simple. And then here is an example of some of these self-paced programs that I was referring to. We talk about the access, the SolarArc integration, our new energy storage system as well. Nathan,
I'd like to point out, Daniel, so I appreciate you showing people these. We're working to get more of these courses online.
Yep.
And for those of you that are on here for NABCEP credits, we have gotten permission to use this new learning management system to actually give you NABCEP credits, just like we have always done here at SimpliPhi Power, for free by taking these online courses here. So keep an eye on this learning system. Right, you can access it by going to Power Academy on Briggs, so poweracademy.com. If you would like a link to that, you can just text the word learn to 33988, and that'll get you a link. We won't spam you, we'll just send you a link. It gives you a link directly to this Briggs website. So again, text the word learn to 33988.
Thank you, Nathan. Yeah, I'm excited to see these online ones get certified. And then you can just do it at your own pace and get those CECs as you need them. And I'm excited for NABCEP conference next year. Hope to see a lot of people there. Last thing I want to just kind of plug really quickly is our Elite IQ installer program. So if you already are installing our batteries, we have a program where we can get you on our maps. So if somebody comes to the SimpliPhi Power website and they're looking for an installer in their area, we can put you on the maps and drive a little business to you. We have a $25 cash back per battery installed. We'll send you some swag, some t-shirts, some hats. We have a level 2 tech support direct line that you get access to. We also have a battery photo contest where it's $250 for the winner of photo contest. So each month we have rolling entries. Send us photos of your installs. I'd love to see photos of homeowners in front of them, or maybe your installer working, or even, you know, the pet in front of it. People in the pictures always tell a much better story. So as we're wrapping up here, that is the email. Please email training@simpliphipower.com if you're looking for your NABCEP credits. Again, this is we were giving out 1 hour credits for this course, training@simpliphipower.com. If you have a question and you haven't already put it into the Q&A chat, now is a great time because we're about to open it up.
And one more thing I'm going to point out here before we move into the Q&As, I saw there's some good questions there, is that we're currently running an Energize America promotion campaign. We've got reduced pricing on a number of our items, and our distributors are passing this along to installers as well. So keep an eye out for that. If you have an upcoming installation, try to buy those batteries before October 31st. We're getting significant discounts. And so if you're an Elite IQ installer, you get that $25 discount on top of additional discounts that you're getting with this program. So it's a great time to be buying these batteries right now as part of this promotion.
Yeah, yeah. Thank you, Nathan. That's great.
Let's jump into those Q&As, Daniel.
Okay.
It's always my favorite part.
All right. You want to start us off?
Go ahead. I got to open it up.
Okay.
I closed it here on my end, but
Yeah.
go ahead.
So the first one, Glenn is asking again, does greater discharge permanently damage the battery, or will it further recover upon discharge? So I believe, are you asking if it's too cold, will it recover? Will those crystals melt?
Does greater discharge permanently damage the battery, or will it recover upon discharge? I'm not sure what you mean here, Glenn. Maybe you can clarify with another question at the bottom, but what I think you're meaning is, does greater discharge permanently damage the battery? So if you cycle the battery at 100%, does it permanently damage the battery? I think that's what you're asking. And if not, clarify below. Certainly batteries are most vulnerable at their highest states of charge and their lowest states of charge. So if you want the longest lifetime out of your batteries, we recommend an 80% depth of discharge, which means you never take it down to that 0%. We recommend that if you're doing it daily. If you're only discharging the battery, if you're using it just for backup and discharging occasionally, discharging down to 100% depth of discharge is not going to cause significant damage, right? But if you're doing it every day, we recommend, not going down all the way to 0% state of charge. Yeah. Not sure if that's the question you intended, so clarify if we need to answer a different one.
Thank you. Yes, someone's asking, what's the difference of charging rate for with and without heating pads? Well, I think the charging rate with heating pads would be the C/2, which is what you're allowed to do. And if you don't have the heating pads, we would want to reduce that charge rate based on that graph that we had seen there.
Right. And
yeah.
So to comment on that, right, it really depends on what the internal temperature of the battery is, yep. Right? And so that's what we have to pay attention to. What are the temperatures of the cells, right? So the heating pad underneath the metal case of the battery on top of a piece of insulation would assuredly keep these batteries within that temperature range that they need to be. And so Daniel is telling you, that rate of C/2 is what you can charge the batteries at if they're in the appropriate temperature range of above freezing, right? If we go below freezing, that charging rate has to be throttled back according to the specs that Daniel gave. And we want to make sure that I would highly recommend the SimpliPhi battery because it can communicate to the charge controller, the inverter, what rate it should be charged at.
Yeah, exactly.
And if you should keep you in the appropriate range.
Yeah, yeah. And if you do come across a site, maybe you're doing a lead acid battery replacement and they have some old Magnum or some old Schneiders that's not able to communicate, go ahead and use the standard Phi batteries. Just make sure we get in there and we implement one of those third-party strategies like that Victron controller there. Are Phi 3.8 batteries approved to fly? I believe they're fly locally. I'm not sure if we're able to fly them internationally.
Yeah, that's a great question. And I think that the answer is yes, but we'll have to get back to you on that. So if you don't mind sending us an email, we'll check with our operations manager to make sure that we can fly these internationally.
Yep.
So it seems like that's what you're wanting to do there.
Yep. Barry Whitmore, I see you're asking about commercial uses. We absolutely do have. We have an entire commercial division, and some of the commercial applications do use some of these batteries that I mentioned, the Phi, the SimpliPhi, or the newer SimpliPhi battery. But the OEM, the commercial division has our own high voltage solutions, which are battery racks and potentially even containerized solutions where a 20-foot or a 40-foot container, all you do is pour a concrete pad for us and we'll come out and drop a container. Email training@simpliphipower.com and I'll connect you up with that team, and then you guys can work directly. I'm not the expert on that side. Steven's asking, I was curious to why interconnect cables are not recommended when paralleling batteries. I think what you're asking there is why not daisy chain them, right? We can never run our batteries in series, but we can parallel them. There's two ways to parallel, right? You can go daisy chain, which I kind of say negative, 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 and then you come off, positive, 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 and you come off. We are allowing that for our new SimpliPhi 4.98 batteries with 4-aught battery cables in between. That's going to make sure that there's very little resistance between the batteries, and each one's going to work equally as hard as the next. With our 5 batteries, unless you're using our bus bars, which allow you to daisy chain up to 3 batteries, we're asking you to use conductors of the same gauge, the same length, going to a common connection point like a terminal block or a midnight solar combiner. That way, each battery is going to have the opportunity to work just as hard as the next, and we're not going to get any voltage drop between battery wires.
Yeah, so if I can comment on that, Stephen, I mean, your question was, I was curious as to why, right? And the answer is, you know, if you have a conductor carrying a large current load, there's going to be a drop along those cables. And as Daniel was saying, we want to make sure that each battery works equally hard to support the load. And if you're using cables which aren't big enough, right, you'll get a more significant voltage drop from battery to battery, which means that the first battery in the chain would be getting much more demand put on it than the other batteries. So to prevent this, we have 2 options. You can do what Daniel was saying, or you can use very large conductors like bus bars, where you have very small voltage drops. And so we recommend using bus bars. You can get them from us. We also have people that can we have companies we can recommend to provide custom bus bars as well.
Yep, thank you. Glenn, I think, clarified his question. He was asking, can it recover in cold weather discharge building dendrites? Can it fully recover? So can those little lithium crystals melt?
To some extent, the answer is yes. However, if they get to the extent where they actually puncture, then no. So the lithium plating is not an entirely reversible problem, right? So one, if it punctures through the separator layer, no, can't be changed.
Yeah.
If you have lithium formation, so solid lithium dendrite formation, but it's still within the electrolyte layer, so that the lithium is surrounded by that salt, then it can redissolve. However, if it's in a location where it's not in contact with the ions of the salt, then the lithium will not reionize. So yes, it really can cause permanent damage to the batteries, and even short circuit and ruin the batteries in extreme situations. And this is true for any lithium battery, and that's why we always have to be careful to monitor the temperature. So hopefully I've clarified. I'm not a complete expert. I don't know everything about what's happening here. But that's the best answer I can give you, is that it can cause permanent damage especially if it punctures the separator layer.
Yep, thank you. 2 more questions, unless somebody else adds one. Oh, I see a little bit more. Any recommendations for keeping the batteries cool in the boss cabinets? Looking at installs in Southern California in the desert, and how any sun and cabinet can be high temperature. We can add fans. Go ahead, Nick.
Yep. Yeah, this is a great question. And I think, Brian, one of the nice things about having batteries inside a cabinet is that the cabinet itself, our cabinets are white and reflective to sun, right? And being white means that they don't give off as much heat in cold environments, and that they don't absorb as much heat in hot environments. Dealing with the sun is a lot easier than dealing with low temperature, right? You can't prevent the cold from getting into places, but you certainly can just shade these batteries. If ambient temperature gets very hot, right, you could end up with problems. We have fans already built into our cabinets, but the nice thing about the batteries is that they have what we call thermal mass, right? It takes a long time to change the internal temperature. And so when they're inside a cabinet, which shields them from the sun, the batteries stay much closer to the average temperature from daytime to nighttime, etc. If you're still experiencing problems, right, I mean, one of the best things that you can do is just make sure that they're in the shade. A very cheap way to do this that I've installed recently on my back patio here in California is just installing a solar sail, right? It's a $30 sunshade that goes up. It's over your battery installation. And then other solutions for that, we could go with active cooling if you were in a really hot place, but most of the time, lithium iron phosphate batteries don't need this. But if you want to talk more about this, I'd be interested in talking with you about that.
Yeah.
And so send us an email at training@simpliphipower.com.
Yeah. Thank you, Nathan. Great. The last question from a different Brian is, we do have CSA for our batteries. I believe we're still working on CSA for our new SimpliPhi 4.98 battery.
Yeah, the newest battery is not yet completed with Canadian testing, but it's in process and it will be soon.
Yep.
And then Ross, what did Ross ask there?
He is just saying, thank you. Thank you,
great.
Ross. And Brian, thank you. If you are looking for those new 4.98 batteries, we're starting to ship them. Ask your distributor, and we will be looking forward to everyone at the next meeting. We do these weekly. Check out our training calendar. Check out our website for some of these recorded meetings. Everybody's going to get a copy of this recorded presentation. If you need your NABCEP credits, please go ahead and email training@simpliphipower.com. Nathan, thank you for joining us today, and thank you everyone else for being here.
And one more thing, if
Yeah.
you are on our email list, watch out for these in-person trainings. Daniel and I are traveling around the country. We have another trainer that's going to be joining us, Chuck Holding, and we'll be traveling around to different distributors throughout the country. I think we've got 6 or 7 trips planned just this year alone, coming up in the next couple of months. And so if you're interested in doing an in-person training where we are demonstrating the functionality of our newest product, this inverter, a vertically integrated inverter in our new battery system, then respond to some of those emails, and
Yeah.
we'll meet you in person and do one of these trainings. So
Yeah,
thanks a lot.
Great. Thank you again, Nathan. Take care, everyone.